Welcome to today's episode of On the Rocks. I'm so excited to have you all here listening. This episode is sponsored by KPI Mining, and we are so excited to have them on. KPI is a business and technology consulting firm that uses data and analytics to drive innovation for clients across 15 industries. With over 20 years of experience, over 600 projects delivered, and over 350 satisfied clients, they build more than solutions, they bring innovation to life. Today is fun because we chat not just with one guest, but the team. We have on Benny Cohen, President and CEO, Mateus Faria, and Giovanni Santos. Today we're going to cover stochastic mine optimization. What is it? How does it address the uncertainties inherent in exploration and mining? And how can you leverage this technology to improve a project's net present value, or NPV? With that, pour a drink and let's dive in. All right, welcome to the KPI team. Really excited to have you all on here on the rocks. What are you all drinking this morning or afternoon, depending on when people are listening to the episode?
I'm drinking Canadian whiskey, so I don't know. Giovanni, what are you drinking?
I'm drinking Kahlua liquor with coffee.
Okay.
Perfect.
Emily, just don't tell my boss that I'm drinking Bailey's like at 8:30 a.m., right? Don't tell him.
I'm not saying anything, and I'm not telling you what's in my coffee mug either. So
All
yeah.
right.
Right.
Well, I'm really excited again to have you all on here and explain a really cool topic. But I wanted to go into this idea of uncertainty and why do some mining projects fail? Because I know that's part of the problem that KPI is solving. So could you explain to me a little bit about that?
Emily, we believe that there are many reasons why mining projects, they fail, right? There are problems in getting permits or problems related to the fluctuations we have in the market. But we really believe that the most of the projects, they fail due to uncertainty, the geological uncertainty, by not we are not really understanding the distribution, the spatial distribution of grades, rock types, etc. in the ground. This leads to misleading production plans and hence misleading production forecasts. So it's not we are not really assessing the economic potential of the mining projects, and that's why we believe that that's the major reason why the projects fail. And this is not KPI Mining that is only saying that, right? Many studies of regarding failures in many projects have shown the major reason is usually related to the geological uncertainty and variability. And even if we look in more up-to-date reports, right? All the large companies, they're reporting every year the productions. We really see a gap between what was predicted in the year before and what actually happened in practice, right? And this is a challenge that we're trying to address with our technology.
And at the end of the day, even the mining projects that are very successful, because of uncertain predictability, overestimating or underestimating, they're actually leaving a lot of money on the table. So they're very successful, but they could be a lot more successful if they had that visibility into a more accurate production schedule. And this is what we're solving right now.
So just to clarify for our listeners, because they hear different episodes on exploration and development, different stages of a mining project's development, what you all really focus on is once you've gotten past that point and we're talking about the modeling of the mine, right? And the production modeling. Is that correct?
Yes, exactly. For greenfield or brownfield or even for operating mines, right, we will always have issues regarding the availability of exploration data. Based on this very sparse data, we need to come up with a model of the mineral deposit. So we are trying to interpolate or understand what we have in between two sample data, right? And now this we have an inherent uncertainty. It doesn't matter how how much data we have. Doesn't matter in which stage we are in the mining, the life of mine, right? We still will have uncertainty. And that's what we're trying to address. We can, based on this data, we can generate simulations of the mineral deposits, so as opposed to using a single model that is traditionally being used. And now that we have multiple simulations, we can now use the simulations as input for the mine planning process. Because we really believe that the mine planning, the long-term planning, it really derives all the cash flows, all the strategy of a mining project, right? So that's what we're trying to address. Our technology is to optimize the mine production plan, but we do that in a different way because we are now enabling the companies to use the statistical simulations as inputs for the mine planning process. And in doing so, we can manage the risk, generate more reliable production plans, right? Are that have a higher economic value, higher NPV, but also lower risk in terms of being materialized in practice. Um, so that's
So how early do you all start, like how early in the discovery and development and, process do you all start to work with the data? Do you come in at a certain point or really, like you mentioned, are you working as soon as they're starting to characterize the deposit and starting to model out what it might look like?
Yeah, so as I mentioned before, we can start very in the early stages to assess the feasibility of the project, right? We can apply this stochastic optimization solutions to assess the feasibility of a mining asset,
Okay.
but also once the mine is uh, producing, right, under production already, we can also re-optimize the remainder years of operations and get higher value, higher certainty.
All right, I'm going to ask you guys to do a little bit of a 101 question because a lot of our listeners, they're interested in the mining and exploration space, but they might be new to it, or we might have folks who, just like myself before I met you all, had never heard this phrase before. So could you explain a 101 level, what is stochastic mine optimization? Like, what does the word stochastic even mean in this context?
Stochastic, Emily, means under uncertainty or accounting for uncertainty, right? Maybe a probabilistic approach. So as opposed to a deterministic approach, which is what we are conventionally using in the mining industry, right? Every time we are doing optimization in mining, we're usually relying on a single scenario of the deposits, a single scenario of price, single scenario of recoveries, equipment parameters, right? Of course, we run multiple times, we do sensitivity analysis, but each run per se is deterministic. What we're trying to do, on the other hand, is to do a stochastic approach, even though this term may be scary, right? By the stochastic, it's let's come up with the scenarios, multiple scenarios based on historical data, based on our exploration data. Let's come up with multiple scenarios and optimize looking at all scenarios at the same time, right?
Mm.
So right now, your plan, your production plan is not the best for one scenario or another. It will be the best for all scenarios at the same time. So this is what
Mm.
enables us to generate more risk resilient plans, right? Because right now, I don't have a plan that was based on a single realization of the deposit. It's a plan that look into account all the possible grades that a block may have in my mind.
And when you develop a plan in that way, do you then develop a multiple, you develop multiple courses of action for how you can manage that mine so that the mining company can adjust when they hit when they learn new things, or do you still end up with one modeling plan at the end, just the one that is best optimized for all of the potential options?
Emily, that's a very good question because normally people believe that, as Matteo said, we are using multiple different scenarios to do an optimization, and normally people believe that the final output would be multiple outputs.
Mm-hmm.
But the reality is we are using multiple scenarios, but coming to a final one single result.
Mm.
And as an impact, of course, as our inputs, they are probabilistic, they are under uncertainty, our outputs will deliver not a deterministic forecast. We're going to have what is called a probabilistic forecast. It is based on some statistical data of what you are planning to get over the years, and it has a certain interval of confidence. So you get some probability associated with a final number you are reporting for the future results.
Okay.
At the end of the day, if I may just add, I mean, what it's about is the fact that you have so many uncertainties, whether geological uncertainties, operational or market uncertainties, and with all these uncertainties, the challenge is to come up with a fairly accurate forecast. And this is what we're trying to solve: is provide the mining companies with a much more accurate forecast, despite all these uncertainties. And this does not exist today. Today, you're getting one scenario that could be right or wrong. We're actually giving you or providing the market with a plan that is a lot more certain, given and taking into account all these multiple uncertainties that inherently exist when you're mining.
And where did this technology come from, or how did it start to be used in the mining industry?
So it has been used actually in the oil and gas industry for forever, right? And we
Mm.
are actually the first ones that are bringing the stochastic optimization to the mining sector. It started with the McGill Cosmo School of Mining Engineering, and they have been developing and conducting research and development for the last 12 years in concert and in partnership with a consortium of large mining companies like Newmont and BHP and Vale and a few others. And essentially, this research has been around, and for the last 2 years, they've asked KPI Mining to take all this research and bring it into an actual product that could be used in the marketplace. And it has been out for at least a year now, and it's being utilized by a lot of companies today, and they're realizing tremendous value.
That's amazing. So it was really built at the request of companies that saw the need for this, but didn't know how to build it themselves.
Exactly. I mean, it's one thing to conduct research on an academic level. It's another thing to take this and turn this into a product that actually works, that users
Sure.
can use, and scales to the largest mines and the most complicated value chains out there.
Yeah. So with that being said, I mean they've asked for this to be turned into an actual product. What benefits have the companies seen from doing this? And how quickly have they seen those benefits?
Right. So the major metric that we consistently see when applying these technologies across different operations is an increase in the NPV.
Mm.
And this increase in NPV is compared to the NPV that we get from a conventional mine planning framework, right? So this is our baseline, and from 5 to 40% higher NPV is what we get, because again, we better understand what we have in the ground, and second, because we're better optimizing the whole value chain. I think I didn't mention that, but our mathematical model has a simultaneous optimization model that is able to better capture the synergies between multiple mines, processing facilities, etc. So first result, and this is being consistently found, is an increase in the NPV, right? Very often we also
Yeah.
find an extension of the pit limits, right? So we're not talking about only a larger pit limits, but the physically different pit limits. So which means that our reserves will be reported differently, because again, it's being driven by different grade distributions we have in the ground coming from the simulations, but also because due to the way we evaluate economically what can be extracted in other periods. So NPV increasing, NPV extension in the pit limits. Sometimes we find extension in the life of mine, right? For some mines that had a reduced life of mine, the technology enabled these operations to be extended a couple of years more. Very often we also find increased recovered metal, and again, this is due to the models we're using, right? We're dealing with the geological models that don't misrepresent the proportions of grades, of high grades. That's where we make money. So we better understand where these high grades are, and for sure this will lead to increase the recovered metal. So, and very often too, we generate reduced amounts of waste, right? This has a critical impact also in the NPV, also has implications, environmental implications, right? We're dealing with smaller waste dumps, right? Smaller potential of generating of acid generative rocks, right? So there are other implications like byproducts that we can get based on the results of this stochastic optimization approach.
Those are amazing. And I think for most folks who are listening have heard me talk with guests about NPVs in the past, but for anyone who doesn't know, NPV is the net present value, right? It's essentially the value of that project at any given time as you continue to develop it. Right. So when you all are using this approach, it increases the value of the project because you're optimizing the mine model for how much of the stuff that's worth money you're getting out of the ore.
Emily, an addendum on what you said when you asked previously how quick a mine company can see the benefits. I want to give you a wider answer on that.
Sure.
First of all, implementing a tool like that, a technology like that, it is a window of something between 1 to 3 months. It's not like long, very quick. And as you also mentioned, what is the definition of net present NPV, which is the net present value? It's all the future income that mine will have, bringing to the present value now with some discount rate over time. Mm-hmm. So the whole formula behind the NPV itself, the most you can profit as soon as possible, the better for you over the time. So for that being said, if we're doing something as Matteo said, we are better understanding the certainty variability, and we are delivering higher value with a better sequence of extraction. Mm-hmm. We can definitely capitalize on the results of our solution in the first year, right? Just at the end of one first cycle of mining, you can already see a huge impact on implementing the stochastic mining optimization tool.
Interesting. And how is the model integrated in when, like, if a company already has a plan, right? Can you guys still come in and help them implement a better plan? And how does that happen? Like, how do you actually implement these changes with a customer? What does that look like?
So these technologies, right, represent a paradigm shift in the way we are doing the mine plan, right? So it's not just replacing a software. It requires a lot of changes everywhere, from the geology teams that needs to provide the simulation. So they need to learn and come up with the simulations of the mineral deposits, the way we process the data in order to import to the software, and the way we deal with the results. Because right now we are outputting probabilistic forecasts. So we're not just coming up with a single curve of NPV, we're coming up with the ranges of NPV, right, for your deposit. So I can tell you what is the expected value you may get, but also what are the ranges or your confidence level for any forecasts we are generating. We don't expect that the companies will right away replace their technologies with our technology. So this process of change management usually starts with a proof of value project, So we benchmark our solution versus another solution. Then we may go to a more elaborate project, which is usually implementation project, right? It also requires training, right? It's uh, training on the concepts of stochastic mine planning and also training on the software because again the workflow is quite different. So we have a step-by-step change management process, right? It doesn't happen
Okay.
from one day to the other, right? It takes a bit of time, training, investigations. People criticize a lot, right? We get question every day, so it's a battle
Yeah.
each day, but the results are really proving the value for this companies.
I can imagine from a big picture perspective, the world needs so much more metal to be produced, so much more to be mined than is currently basically in the workflow, right? The projects that we have in the pipeline for development and construction. So anything that can be done to better optimize the existing mines. So we're extracting, with any kind of environmental impact or social impact, we want to make sure that we're getting the most benefit we possibly can from any of these activities in order to justify or contribute as much as we can, right? Um, so it would make me wonder if there are regulatory aspects to this, right? Is this something that governments can support in some way, or that you anticipate will change regulations around a mine?
I mean, if anything, just to give you some examples, we are dealing with certain companies or certain cases where, with the traditional deterministic method of understanding what the potential NPV would be, the conclusion is that the that project is not investable.
Ah, okay.
As soon as they start looking at our solutions and they look at the potential results on, from an NPV perspective, all of a sudden it is investable. So it does make sense to invest in certain mines that they've already invested a lot and continue the investments because the output will be there.
Hmm.
So big change, even from that perspective, So to your point, we do need the metal, and then
Hmm.
when certain cases they'll conclude that that's it, we're going to stop production. There isn't enough there to justify all the investments. With our solutions, we're giving them a different perspective.
No, that's fascinating because as you guys mentioned earlier, because you're also modeling for things like price assumptions as well as the geologic uncertainty, you can come up with scenarios basically that allow a mine to extend that mine life, as you mentioned, right? So there are ways to better optimize it to make the mine last longer and maybe under lower grade conditions or different economic conditions.
Yeah, Emily, uh, your question in terms of regulations. Basically, nowadays, all mine operations they respect some national regulations
Hmm.
in terms of how they report the reserves. The idea behind it is to get security for the investors that those mines are reporting the reserves according to a specific code, which is which is managed by a certain association with mine engineers and geologists, people who specialize on that. And the main ones are the codes in, let's say, Canada and Australia. US has a strong code as well, but the main ones are the NI 43 101 Canada and the JORC in Australia, right?
Right.
Over the time, these codes, honestly, those codes, they were never constrained by any type of technology that you should report your result.
Mm.
At the end, it is managed by the qualified people who are people capable or as the name said, qualified to sign up those reserves. But what happened is another day I came up not I came up, I was reading one article that maybe 30 years ago, no bank in the world would financing a mine operation that was not running open pit optimization with a specific software using a Lash-Grossman algorithm.
Mm.
So one day, the Lash-Grossman algorithm was developed, and then that was brought into a software, and it became as a default standard in the market. Of course, some mine operations, they were reporting without using the Lashley-Grossman algorithm, but at the end, a bank were not investing or not providing money to the mine operations that were not using that tool. So consequently, nobody was reporting without using that. So we believe that one day it will be the same regarding the stochastic mine planning. It's just a matter of time. It can be 5 years, 10 years, or 1 year. Every single mine will be reporting like that, but we are not on this stage yet. But in terms of regulations, there is no constraint on using stochastic mine planning optimization tools.
So you could imagine though, then certainly if we have a lot of mining company investors certainly that listen to the podcast. So this would be something that they could go back and ask about when they're doing diligence, or even if there are companies that are already in their portfolio that they could inquire about, right? To find out if the company is using stochastic modeling with the different projects.
Absolutely, absolutely. Both from a different perspective on the potential outcomes, and should they invest, should they not invest, does it make sense, does it not make sense? I mean, we're giving them a more accurate perspective on what the outcomes will be,
Yeah.
and therefore they can rely on the results.
Yeah, and again, it also goes back to the way we are reporting the forecasts, right? Right now, we only have a single answer,
Right.
right? The reports will tell these are the tonnages they will produce, this is the metal we're getting, and this is the NPV we're getting, right? But we don't see the risk involved in these forecasts,
Right.
right? Because I can have a forecast that has a very high variance, right? Or I can have a forecast that's a much lower variance. And more than that, I can have a project that two projects with the same NPV, but one has a much higher upside potential than another one, right? One project compared to the other, I may have a much lower downside risk than the other. So right now, the decision making about investing or not investing in a project is not only regarding a single response of any production forecast. I'm talking about risks, right? That's the beauty of the stochastic optimization approach. We optimize, we may get better results, but we are also reporting probabilistically. We understand the risk involved in each production forecast that is generated. We know the probabilities, right? So we know what is your 80% confidence interval. We report everything in terms of percentile. So this also requires a change of a mindset, right? Because now we can make decisions in a much more informed way, right? Accounting for the probabilities, accounting for risk. This is what the oil and gas industry has been doing for decades. They deal with uncertainty and variability much better than us in the mining industry. And these concepts that we're trying to leverage for the mining industry.
No, I mean, I think that's such an important shift, because mining, of course, is always about risk mitigation, right? I mean, that's what you're doing throughout the whole discovery, development, and operation process. So I think that's fascinating, and the ability to better communicate internally, I would imagine as well, about the risks and the options for mitigating it in the operation of the mine, but I mean, economically and geologically speaking, because Lord knows you never get 3 or 4 geologists to agree on on what something looks like, right? So maybe having a model, it at least helps level the playing field. And I say that as a geologist.
So, and I mentioned that from like an investment standpoint, right? How these probabilistic forecasts may help the decision-making process. But we have the operational side of things too, right? Right now, I can look at the forecast, for example, for our production, and understand based on the results that some years will be riskier than others, right? Oh,
Right.
for this year here, I wouldn't like to have that, but this is a result that I'm getting. I know that for year 3, I have a high probability of having a shortage in my ore production. But the stochastic approach is anticipating this risk, right? This probabilistic forecast is telling you in advance, be ready, right? So then the medium term and the short term plan, they can adjust their strategies in order to account for this risk that has been anticipated, right? Right now, we're
Mm-hmm.
making plans, but we don't know the related risk of it, right? And we're going to the operation assuming that forecast will be met. And very often, what happens is we never meet the production forecasts because we don't see the
Right.
risk, right? So there is also the operational side of that that is beyond the investment perspective.
No, that's absolutely. And so with that, speaking of things that we wish we could see, the question that we ask all of our guests here on the rocks at the end is if you could wave a magic wand and change one thing about the mining industry, what would you change? And I want to hear an answer from each of you. So who wants to start?
I mean, sure. I mean, look, from our perspective is, we know that the mining industry is fairly conservative, very reluctant to change. I think that the name of the game here is to keep your minds open to something completely new, and try to understand what this paradigm shift is all about. There is a lot of
Mm-hmm.
education that we're going through right now, even evangelism on the whole concept, right? We would encourage the mining sector to be a little bit more open-minded to this new way of optimizing your mines, because at the end of the day, the results are amazing. We're saying this because we have papers to prove it. We're saying this because we have already delivered multiple projects that have shown this the results, and we're saying this because it's been around in the oil and gas sector for dozens of years, and they've been using this very successfully. So open mind.
Love it. All right, Mateus, how about you?
Hmm, good question.
You can't just say, "But I would make everybody use KPI." That answer isn't allowed.
Yeah, we wish, right? But I think um, my answer is quite connected to Ben's one. I think being a bit more innovative in terms of adopting new technologies. That's the change I would like to hear. We do see a trend, right? We're talking
Hmm.
about a lot of machine learning models that the companies are trying to integrate new technology, sensor data. So we see a trend of innovation, right? But I just would like to see a bit more.
I'm with you on that one. Absolutely. Giovanni, what's your answer?
I would try to answer a bit different than then. I would say that I would not change anything in the mine itself right now. I would like to change the years we are seeing the mining on,
Mm,
and for that, I'd like to see how the mining be will be done 100 years from now. And let me tell you why. Because when we look in the past, on the last 2, 3, 4,000 years, people moved across the world, always trying to find gold, silver,
mm,
different metals over time. That's how, at the end, South America was colonized. That's why the Europeans they went to Africa to colonize, always finding for resource metals. And we are living on the early stage that will be happening 50 or 100 years from now. The human race will be going to other planets to find not land but find resource.
mm.
So I'd like to be living on those years, seeing we're gonna be mining an asteroid or in a different planet.
Absolutely. Awesome. Well, with that, thank all three of you for joining us on the rocks. And listeners, if you want to learn more about KPI or stochastic mine optimization, you can listen for that in the intro and outro to this episode. And we'll, of course, share it on social media. So thank you all again so much for joining, and we look forward to having you back on sometime soon.
Thank you very much, Emily.
Thank you so much, Emily, for the opportunity. It was a great pleasure to talk with you.
Thank you again to KPI Mining for sponsoring this episode of On the Rocks. If you'd like more information, check out kpidigital.com to learn more, or visit them at their booth at PDAC 2024, booth number 6729 North.